Howdy, folks. This is the pedigree justification activity that you have in your notebooks. So what you're going to be doing in this activity is looking at several pedigrees and trying to justify what type of pedigree is being shown. Now, there are multiple answers for a lot of these. And so the way College Board could pose a question would be justify that the pedigree below is this type of pedigree. So it could be autosomal dominant, autosomal recessive, or sex-linked. And if it's sex-linked, it can still be dominant or recessive. So what I'm going to do is I'm going to use this designation, autosomal dominant, AD, if a pedigree is showing that it doesn't skip generations and it affects males and females equally. I could also use AR for autosomal recessive, and I'm going to do that if I notice that a pedigree does skip generations. It may or may not, just depending on the pedigree itself, and it affects males and females equally. If it affects males and females equally, it is autosomal. Sex-linked, you're going to see a pattern that one sex might be more affected than the other. So you have, not on top of having dominant or recessive, you also have what is known as X inheritance or Y inheritance. And so there's a lot of factors that we got to look into, thinking about these as a puzzle and figuring out what they could be versus what they absolutely are not is going to help you. And then keep in mind that the smaller the tree is, the less evidence you're going to have to eliminate or support a choice. So if a tree is very small, you're not going to be able to eliminate as many of these as you would if you had more information and more members of a tree to follow. So let's get started with the actual justification trees itself. So you're given here a very small tree, very few individuals, one family, in fact, and we're going to try to justify whether or not this is autosomal dominant, autosomal recessive, or if it's sex-linked. And if it's sex-linked, we're going to try to figure out if it's if it's dominant or recessive. One of the new things that you may notice on this tree is the presence of this branching right here. This represents a set of twins. So the females are shown as circles, the males are shown as squares, and the shaded individuals, like you see here, are the ones who are affected. So let's start with autosomal dominant. We're going to go through this list for each of these to see if we can eliminate or support the claim that it is that type of pedigree. Looking at this right away, I noticed that this cannot be autosomal dominant. And the reason I know that is because it doesn't skip generations. If this two right here are affected, they had to have inherited, if it's autosomal dominant, they had to have inherited from one of their parents, and their parents should have been affected as well. But you can see here, both parents are unaffected. So I'm going to eliminate autosomal dominant. Next, I'm going to check, could this be autosomal recessive? We notice that it does skip a generation. So if this individual, let's say, if both parents had been heterozygous, and I like using the letter A because it's very easy to distinguish between a capital A and a lowercase a. But what you'll notice here is both parents are unaffected because they have the normal dominant condition, but they are carriers for the recessive condition. So even though they have the recessive condition, they themselves are not affected. But these individuals here are going to inherit one of these from their mother and one of these from their father. And so what must have happened, or to justify that this is autosomal recessive, we would say that these individuals both inherited the recessive trait. So the lowercase a from the mother went to this individual, and the lowercase a went to this individual in the father. I'm sorry, I should say it came from the father. And the same thing happened with the second son. The twins, on the other hand, must have inherited at least one working copy either from the mother or the father. Now, we can't tell if these are identical twins or unidentical twins, but no matter what they are unaffected. So they must have inherited one of these. We don't know which, but they must have inherited one of these from the father and the mother. And so we write that as a capital A blank. They can either be heterozygous or homozygous dominant, depending on what they inherited. Last, we're going to check to see if this is something that could have been inherited as a sex-linked trait. And so it may or may not skip generations, so we can't use that to eliminate it. And we can see that it also looks like it can affect one sex more than the other. And there's a limited number here, so we don't have that much information. However, just based on that strict definition, we can't eliminate that as an answer choice. So remember that females are XX and males are XY. And I've color-coded the X chromosome in red for the female that has the mutation. Now because she has a normal X chromosome here in black, she does not exhibit any of the symptoms, but she herself is a carrier because she has that X chromosome with the mutation. The father is unaffected completely. So I would know that this is not a Y-linked inheritance, because if the Y had been the mutation, the only way that these two could be sons is if they inherited that Y from their father. If they inherit an X from their father, they would have been female. So since the father himself did not carry the Y chromosome or the mutation in the Y chromosome, this is not a Y-linked inheritance. This must be an X-linked inheritance. So in this case, what would happen is the mother is most likely a carrier for this condition, and both of these sons inherited that defective X chromosome, and they inherited the Y chromosome from their father. Now for the twins, they could have inherited the X chromosome from their mother. They had a 50-50 chance of inheriting either a normal X chromosome or, let's change colors here, they could have inherited the Y chromosome or the X chromosome with the mutation from their mother as well. So it's a 50-50 chance. But from their father, the only thing that he can donate is the unaffected X chromosome, in which case the daughters would be homozygous for the normal X chromosome or heterozygous for the condition. And because they still have this normal X chromosome, they do not show the symptoms of the disease. Had this been X dominant, then they would only need one copy to show the condition. So this is probably, most likely, if it is a sex-linked trait, is going to be an X recessive trait. Let's take a look at the next one. So we're going to do the next thing for this tree. We're just going to go a little bit faster now that I've gone through the step-by-step elimination. And so each of these we're going to go through and look at, is it autosomal dominant, autosomal recessive, or could it be sex-linked? And if it's sex-linked, is it something that could be inherited on the Y chromosome or the X chromosome? And is it dominant or recessive? Remember, we're not trying to prove necessarily what this is specifically. We're just looking at what could it be. We're justifying it could be this condition, and it definitely could not be one of these other conditions. So with autosomal dominant, we're going to look at, first of all, noticing that in the P generation, so this right here would be P, F1, F2, and F3. So if you look at this, let's do this in a highlighter. So this is the F3 generation. This is the F2 generation. This is the F1 generation, and then this is the P generation. So the first thing we're going to look at is, does this condition skip generations? And remember to focus just on the offspring of the parents we're looking at. So for example, this individual here is joined with this individual here, but this is not necessarily part of this family tree, although we could use this information to help us determine for this child and then that grandchild. So when I look at this, though, I can prove, or I can see that in F and P, there is the condition present, as in F1, as in F2, and in F3. So this does not skip any generations. Then I look at, does it affect males and females? equally. Now, it may not necessarily be perfectly equal, but there are definitely instances of both males and females in this tree. So, for example, female, female, male, male, and it is not necessarily perfectly equal, but it is present in both males and females. So we are not going to eliminate autosomal dominant from this tree. Next, let's look at autosomal recessive. So it may or may not skip generations. We see that it's present. And again, it affects males and females equally. So we don't have enough evidence to eliminate autosomal recessive as this condition. And then the last is sex-linked. We don't see, we see that looking at whether or not it skips generations is not going to help us. But we really don't see one sex affected more than the other. So in this case, we would not eliminate, or we could eliminate that sex-linked option. On this one, we don't really see one sex affected more than the other one. So it's not likely that this is something inherited on the X or the Y chromosome. So this could be autosomal dominant or autosomal recessive. For the next one, we're going to do it a little different. Now, what I'm going to do is I'm going to ask you to justify a particular condition for these pedigrees. So on this one, we're going to focus on justify that this pedigree could be for a condition that is autosomal recessive. In your justification, it may help if you identify individuals by numbering them. And be sure to give specific examples of genotypes for the individuals and talking about how that individual came to be that specific genotype. In other words, what gametes did they inherit from their parents? For this last tree, you are going to justify that this pedigree could be for a condition that is sex-linked. Not only are you justifying that it is a sex-linked condition, you're going to justify using specific individuals and specific genotypes for the X-linked dominant condition. Remember to cite specific individuals and specific genotypes and the gametes that were produced to produce that individual. Make sure on this one you provide solid evidence that it is sex-linked, more specifically X-linked dominant. If your evidence doesn't justify that particular one, it will not be sufficient. There's one more additional page where you will be drawing 2 pedigrees. Make sure that you don't forget to do those as well. Thanks for watching. Bye.